Hi, good morning, Miss Anna. This is Furqan Ahmed Muhammad. Today, I have a few slides of presentation for fire resistance of concrete and masonry construction. So now, when we talk about concrete and fire, we the basic nature we need to know about the concrete. The concrete is a material that does not burn. It cannot be set on fire, and it does not emit any toxic fumes when affected by fire. Concrete is proven to have a high degree of fire resistance and in majority of applications can be described as virtually fireproof. This excellent performance of concrete is the main because of its constituent materials such as cement and its fine aggregates, coarse aggregate that chemically combine within control concrete to form a material that is essentially inert and importantly for fire safety design, which has relatively poor thermal conductivity. If this is slow rate of conductivity, heat transfer that enables concrete to act as an effective fire shield not only between adjacent spaces but also to protect itself from fire damage. So now when the concrete structures perform well in fire because of combustion of inherent properties of the concrete along with appropriate design of structural elements to give required fire performance and the design of overall structure that to ensure robustness. Fire performance is the ability of particular structural element that is opposed to be any particular building material to fulfill its design function for a period of time in the event of a fire. In this context, we're going to look over its controlling factors, then what is fire rating, comparison of fire rating in different concrete types, factors affecting fire rating, and few calculated fire resistance methods, and the methods that can improve fire resistance, and few references as well. So, when we talk about fire resistance, what is fire resistance? It's the ability of concrete to withstand fire or to give protection against fire. The components of concrete, such as cement, sand, fine aggregate, coarse aggregate, which are chemically inert and hence these are mostly non combustible that possess slow rate of heat transfer. According to European national standards, particularly mentioned in the slide, has specified that the fire classification for particular construction products and building elements in which concrete is classified as combustibility class A1. There are few factors that control fire and that is divided into two categories. The one of them is the physical factor and the other is the thermal factor which need to be considered. Like in physical factors, the stress level, steel ratio, concrete cover, the tendency of aggregate and fire free moisture to cause spalling, and the lateral restraint conditions to be considered. Whereas in thermal factors, we must be looking over the type of aggregate, the free moisture in the concrete, and the volume of concrete per square meter of exposed area. Fire rating. So, according to ASTM, the fire rating is termed as a duration of time that concrete element can endure the fire. There are many international standards as well that describe fire rating as the same, which has been shown here also in our slides. So, but in particular, section 703 of ASTM, it is prescribed the standard fire test that has been considered for walls, floors, roofs, columns, and beams. So when we talk about the concrete fire, we must also look over the, the different particles of concrete, the different types of aggregates used in concrete has different effect. Like some can be good, some can be bad. That mean like the aggregate we are using, for example, the siliceous aggregates that that is considered to be the best fire resistance performer, and whereas carbonate aggregates are just good fire resistance, and the lightweight are the very low fire resistance performer. And the table describes the different concrete types and the hours that fire resist. For 1 hour of siliceous material, it is like 3.5 hours. So the whole table has been shown here in this consideration. So when we talk about the concrete materials and its effect, we must also look over the main factors that affect fire rating. Like there are mainly four factors that affect fire rating. The most among them and the top of them is moisture content. That is like water cement ratio. When there is low water cement ratio, there will be low fire rating. Secondly, density. How then the weight of concrete per cubic meter, when it is lightweight in concrete, that performs better in fire resistance. Thirdly, there is permeability. So higher permeability concrete poses better fire rating. And lastly, the thickness. The thickness of concrete also affect fire rating. As thick the concrete are, the better the fire rating is. There are few calculated fire resistance method from ASTM which measures from four performance criteria, that is to resist to transmission of heat or to resist to passage of hot gases through masonry wall, concrete wall. Thirdly, load carrying capacity of load bearing walls and the resistance to the impact, erosion and cooling effects of a hose stream on the wall assembly. The same calculated fire resistance per particular hours depending on a type of aggregate has been shown in this table. For, for aggregates such as expanded slag, slate, unexpanded slag and siliceous gravel. So the values from the table can be determined by direct interpolation. The but the requirements of for the standards mentioned here shall apply. There is also one thing important to understand, that the minimum required effect equivalent thickness corresponding to hourly fire resistance rating per unit with a combination of aggregates shall be determined by linear interpolation based on percent by volume of each aggregate used in the mixture. Now, finally, there are like few methods that can improve fire resistance and that need to be considered. Firstly, fire resistance of concrete can be improved by the use of aggregates consist of lime, rock, limestone, dolomite. As they are exposed to heat, they will heat up calcine and will liberate carbon dioxide from it. Secondly, spalling in concrete due to the heat temperature can be reduced by such use of polymers or polypropylene monofilament fibers. The usage of heat shields that are coated with indument paint can also improve fire resistance, and also usage of protective boards and many more, etc. So these are the few references mentioned here. Thank you.